Welcome back. Today we're fixing the battery light on my e-bike. So my e-bike is a 72 volt e-bike. I could step it down and use the main battery for that, but I don't really have a step down transformer or anything like that. And it needs to be around 12 or 24, I think up to 60 volts for my light. And I don't have that. But I do have some other pieces floating around. So I'm gonna make a 12 volt lithium ion battery with just pieces that I have laying around. So here's what we have today. And here's what we want to do. So here's my light, and it's connected with a switch. I've got a toggle switch, and then I've got this cord that comes around here, and then down here, and then here, right now is my little external thing that I wired up just barely. It's there. I just strapped it on just to see if it was going to work. It works. Technically it works, but I got my flashlight. Look at just a random 5 LED flashlight and the bulb itself. Not very bright in comparison. So we need to fix that. So let's go through a little history. Previously, I had this light right over here connected to a battery that looks similar to this. I used to have a small, tiny lithium ion battery connected to it before it failed. And these are just old cells, 12 volt lithium ion, 3 cells. So here's the plan. These are just lithium ion cells. I have some old cells just floating around from old builds. Cells, just individual 18650 cells. These are kind of standalone. I just kind of have a few of them from other battery packs. So I'm not going to spend any money on this particular build. So there's a couple reasons why I'm doing what I'm doing. I had to mix a couple of these cells. These are 3200 milliamp hours. They test at about 3000 milliamp hours. This was a brand new cell. This is 4000 milliamp hours, 35 amps. So this one's quite a bit more powerful than the rest of these. These are 10 amp cells. This is a 35 amp cell. So I'm mixing this particular cell. The only reason I'm mixing it is because it's more powerful and it has more capacity. So it's not going to drain, it's not going to put a load on any of these other cells. And this is essentially going to be as small as these cells when it comes to connecting them, because I'm going to connect them all in parallel. They are running, they're at about 3.65 volts each. Some of them are 3.69 volts, but they're around 3.6, 3.7 volts, so we won't have any issues putting them in parallel. When we're doing 12 volt batteries, there's going to be 3 rows. So we're going to put this little topper on them so we can set them in place. And it's going to look like that. We're going to have a top and bottom, nice separation of cells. Then we're going to connect our little BMS to it. We have our 0 volt here, then we go to 4 volt, then 8 volt, and then our 12 volt right there. And then we have our positive and negative. So this is going to be our battery 0 or our battery negative, and this is going to be our battery positive right there. And then we're going to connect each individual cell up to 4.2 and 8.4 volts. And then our charge and discharge is going to be these connections right here. It's going to be the same connection. So we're going to use that both for charge and discharge, or we'll just split it. Doesn't really matter. Okay, without further ado, let's get into actually wiring this thing up. I am going to be using the 801D for actually doing the spot welding. You do not need a spot welder this large. You can use a mini spot welder. Those work perfectly fine as well. I really like a few of the mini spot welders. I'll link some in the description. I'll also link this. Again, this is for like the bigger batteries if you want to just continue to weld and weld and weld and you don't ever have to stop. Or if you're doing a battery and you want to take a break every hour, those mini spot welders work really, really well. So right now, and this thing takes like 20 minutes to charge anyway, so it's going to take 20 or 30 minutes. It's at 0.7. I think it needs to get to 5.2 or higher in terms of charging, and we're on 30T in terms of the power. So those are my settings for what I'm going to spot weld today. And yeah, let's go wait 20 or 30 minutes, let this thing charge, and I'll see you in a sec. Okay, here's the 12 volt 24 amp hour battery that we're going to spot weld. We have some nickel plated steel, and we have some pure nickel here. So as you can see, the plated nickel sparks way more than the 99% nickel, which is why I like to use the nickel. This is only really rated for, I mean, maybe 5 to 7 amps, but I'm not going to be pulling anywhere near that, so I'm okay using it. I would not use this for any high capacity battery that I would be making. Okay, when we weld the positive side, see we have the negative here. We want to pull the positive from over here. So this is the positive can also be over on this side, right? We don't want to drain from this side and pull from this side, because then we can just use these 3 batteries over here. We want to have them on opposite sides of each other, so they are forced to use the whole pack, so everything stays really balanced. It's going to balance itself anyway, but it's just a better way to build. This is 100% nickel. This is the difference. See how it's not sparking nearly as much even when I mess up a little bit? Oops. This is the positive side, so it's harder to get both pieces on it properly. But it's not sparking hardly at all. All right, so here's the battery. I can show you from a voltage perspective what we're looking at. So really all we're doing is we have the negative all like this, then we have the tab on the negative, and then that is going to flow through to the 4, and both these sides are going to be 4, so the voltage is 4 for both of these, so we just need one tab over here, and then we're going to put it in series on this side, right? So we're going down, across, this is 4 volts, and then we come up to the top. Now this is 8 volts across both sides, and we're putting these in series as well. So parallel, series. So this is 8 volts, 8 volts. Then it's going to flow through the battery. Every time we go through the battery, we gain voltage. And then we're at 12 volts at the end. So we have 12 volts here, 0 volts here, and these are going to be the tabs that I'll connect to. I'll connect to here and to here. I might connect to the top of this because this tab isn't very big, but that's totally fine. All right, but that's it. So we're pretty much ready to go. We've got the positive and negative for the charge and discharge already connected. And now we're just going to connect the negative up, connect the positive up, and all the leads. Hey, we skipped ahead just a little bit. I just packed this battery, just wrapped it in some protection and some duct tape just to make sure it was going to be okay. So it's just kind of duct tape. It's got some soft outer layer in there, but it's the same thing you saw before after we did the connections. Everything's working properly. This connection is going to be both the charge and discharge, so I'll charge it, unplug it, and then it'll also discharge the same way. So cool. We are using the cycle satiator, and this is actually a really cool charger. I really like the fact it was super expensive. It's like 350 bucks, but it works incredibly well, and it works with all my batteries, which is super nice. So I'm charging this up to 12.6, just the very, very top, tippity top, and we're charging at 4 amps, which is super great. So we put 0.28 amp hours in it so far, and it's just cruising right along. Looks like it's got a ways to go, so we're gonna let it go, and then we'll attach it to our bike and test to see if it's any better than what we got on it currently. Thanks. All right, we were able to charge it. I attached it to my bike. We've got it hooked up, and we're ready to do some testing. Let's do it. Let's kick off the light. Turn this thing on. And my super scientific test is blasting it against this bench. So, as you can see, it is quite a bit brighter. Looks good. That's essentially what I was doing before. So, it's actually brighter than my light now, which is really nice. When you look at the wall, you can see just how much brighter it is. It has quite a much better light, and it's throwing light way further than it was before. So there we have it. Works really well. This battery doesn't work nearly as well as a lithium-ion battery that I built. It just doesn't produce the same amount of light at the same voltage. It's kind of confusing. I don't really understand it, because this should be able to deliver quite a bit of amperage initially. It's supposed to be able to deliver at least 2.7 amps. That's not a lot. I mean, this one over here, we can deliver 10 amps per cell, and we have 8 cells. We can deliver 80 amps. We're only going through a 20 amp BMS, so 2 amps versus 20 amps, but still we're only pulling 0.5 to 0.6 amps at any given time. So I'm confused why this one is so much worse than my lithium ion. I didn't connect it to my main battery, so I could theoretically connect it to my main battery. I would need like a step down converter to actually do that, and I need to buy that. So all the parts that I needed to build this battery right here, I already had. Well, thanks for watching, and I'll see you guys in the next one. Bye.